The second part of our video on mid-segments and coordinate proofs. So we talked about using coordinate proofs in the last video. What we want to do here is place a figure in a coordinate plane. We want to put it in the coordinate plane in a way that's going to be convenient for finding side lengths. So we're going to assign coordinates to each vertex. So here's our first example. We have a rectangle. And you can put this rectangle anywhere you want in the coordinate plane. One of the best places to put it is using the origin as one of the vertices. So we're going to put this lower left-hand corner as the vertex. And you could have made it any one of the vertices, but this is probably the best one. That way the entire shape is in the first quadrant. That way we're using positives, not negatives. Now, we want to use variables, so we're going to assign variables for these certain lengths. Let's say that this has a length of, well, we'll just call it x to make it simple. This rectangle has a length of x, and it has a width of y. What we want to do now is figure out where these vertices live. If this is 0, 0, and you go x units to the right, where do you live now? You would live at x0. You went x units to the right. You did not go up at all. Go back to the origin. If we just go up y units, this ordered pair is going to be 0, y, because we didn't go left to right, but we went up y units. Where's this guy going to live? We went x to the right and y up. So it'll live at xy. The second one is a scalene triangle. Let's use the same concept. Let's put the lower left-hand vertice of our shape on the origin. That way we're using the first quadrant. And let's assign some variables. Let's say from here to here, that's this guy, is A units. Here to here is B units. Here to here is C units. So that's 0, 0. We're going to go B units to the right and up 0. For this vertex, we're going to go A units to the right and up C. We're going to do the same thing on this one, except we're going to use an isosceles right triangle in a coordinate plane. We want to find the length of the hypotenuse and the coordinates of the midpoint M. So this is a great place to put your right angle because it's an isosceles right triangle. So we know that's a right angle. And if it's isosceles, whatever this length is going to match. So that really helps you. So we'll call this distance x. So this ordered pair would be x0, and this ordered pair would be 0x. We want to find the length of this hypotenuse right here. And we could do this a bunch of different ways. We could use the Pythagorean theorem if we wanted to. Obviously that's x, and that's x. How long is that guy? Well, I'll redraw the triangle down here. X, x, question mark. How to use the Pythagorean theorem to find that length. Wait, do we know the Pythagorean theorem? Sorry guys, I'm so far ahead in so many different places, I don't know what you've seen and what you haven't. Maybe you don't know the Pythagorean theorem. I think we got to use a distance formula here. Oh my gosh, this is embarrassing. Okay, well I'll do it both ways because I don't I don't remember what you know and what you don't. My apologies. X squared plus x squared is going to give you that hypotenuse squared. We'll call it C. And we have two of those x squareds, If you want your hypotenuse, you're going to unsquare that guy, that 2x squared. Now, when you do that, you can split this thing into the square root of x squared times the square root of 2. And the reason we did that is x squared is a perfect square, so when you unsquare it, you just get x. And this might not look very cool to you, but it actually is very, very neat and very, very helpful. This is x times the square root of 2. So anytime you have an isosceles right triangle, if you know the legs, then you should know the hypotenuse is just going to be that same leg, whatever it is, x times the square root of 2. For example, if this was 5, this would be 5. And this would be 5 times the square root of 2. Now, they also want you to find the coordinates of this midpoint. So where does this guy live? So how do you find the midpoint of a segment? Remember, you average the coordinates of the endpoints. So we have a 0x and we have an x0. We want to add the x's and divide by 2. So our midpoint is going to look like this. That's how you find midpoint, remember. Add your x's, 0 and x, divide by 2. Add your y's, x and 0, divide by 2. 0 plus x is x. X divided by 2 is just half of x. X plus 0 is x, and half of that is x over 2. That's where your midpoint lives. If this is x0 and this is 0x, this guy is x over 2, x over 2. And again, that might not seem like earth-shattering to you, but if you knew this was 5, we go back to that easy example. Let's say this is 5. That's 5, 0. Where does this midpoint live? It lives at 5 divided by 2, 5 divided by 2. It would be 2.5, 2.5. So notice how we're assigning variables for the purpose of solving for every situation, not just the situation where this is 5. This works in every situation. That way you kind of have like a formula where you can put any value you want in there to find a midpoint or a side length.